So today we're doing practice 8.3, which is the standard normal distribution. So from the last lesson, you guys learned that the normal distribution is a function of the two continuous parameters, mu and sigma, so the mean and the standard deviation. That's how the normal distribution works. The mean is in the middle, 1 standard deviation, 2 standard deviations, and 3 standard deviations. And there are an infinite, look at that spelling, wow, number of normal distributions that can be created. I don't love Excel because it doesn't have autocorrect and it doesn't have like spell check. So like as I'm going through this, I find so many things. I'm like, what was I doing? So today we're going to learn about the normal distribution, but it's going to be a standard normal distribution. The standard normal distribution will always have a mean of 0 and a standard deviation of 1. So you guys did examples where like the mean was 3.9 and the standard deviation was 1.7. For the standard normal distribution, the mean will always be 0 and the standard deviation will always be 1. This distribution provides a basis for computing probabilities for all normal distributions. So here we have a standard normal distribution curve, mean of 0, standard deviation of 1. Just a reminder, the area under the curve has to always equal 1. And you guys learned last lesson about how we had like the empirical rule, but a little bit more specific, the 99.7, the 95, and the 68, but a little bit more specific with decimals. It's the same concept, but again, the mean is always 0, standard deviation is always 1. So in this chapter, we learned that translating any normal random variable into a standard normal random variable was called a z-transformation. We could compare two different things, even with two different like labels, by finding the z-score, because the z-score didn't have a label and it put everything kind of on the same scale. So you could tell me who performed relatively better on the ACT or the SAT by using their z-scores. Because the z-transformation gives the standard normal unique status among normals, the standard normal is also referred to as the z-distribution. For this practice, we will be doing things differently than the book or Hawks would like you to do, okay? Here's why. For some reason, statisticians are old school and they're like, you need to do things the same way that we do, so they want you to use these stupid tables. Do you guys see those tables? They're like, use these tables to find the z-score. And that's just asinine because we have Excel. And Excel is literally built with those tables in it. So there's no reason we need to utilize those tables or even know how to use them, okay? So just so you know, if you like are on Hawks and it's like, teach me, ask for help, it's going to teach you to use the table. Absolutely not. I would rather you come back and watch this video. So we will specifically only be using Excel. The book would like you to use the huge tables and find given values for each z-score or area, but Excel already has those tables built into its programming, so we don't have to do the extra work. When working with a standard normal distribution, again, mu of 0, standard deviation of 1, you will be confronted with two different types of problems, okay? The first type of problem would be we know the z-score and we need to find the area under the curve that would correspond with it, or we know the area under the curve and we want the corresponding z-score, okay? Those are the two different types of problems we're going to do today. So for all of these problems that we're going to focus on, there are three givens. First of all, they're giving you that the population mean is 0. That's the whole point of a standard normal distribution. They are giving you that the population standard deviation is 1. Again, the whole point. And then they are also giving you that the area under the curve equals 1. That's just part of the deal, okay? Now, we are going to find the area under the curve in Excel. And to do that, we are going to type in norm.s.dist. Again, that's the normal standard distribution. And then we put in the z-score and we put in true. The reason that we put in true is because true means cumulative. Okay, true means cumulative. Means it's going to, I don't know where that 77 came from, and that means it's going to be up to that point, everything added together. Now, the result of this formula is always the area to the left of the z-score, always. And that's why we're going to sketch a lot today, because it's going to help you understand what in the heck that means. So on number 1, it says, find the area under the standard normal curve to the left of the z-score of 1.27. So here's the thing. What we're going to have is we are going to start off with the standard normal curve. We're going to have this, and it's going to look like this. And if your drawing isn't perfect, it is what it is. It's fine, okay? Since it tells me that it is a standard normal curve, that means that the mean has to be 0, okay? Now, I have a z-score of 1.27. Is that going to be to the right or to the left of the mean? To the right. Is it going to be within 1, 2, or 3 standard deviations? 2, because the standard deviation is 1. So this would be like my standard deviation of 1 right here. I know it's going to be a little bit past that, so I'm going to put where I think the z-score of 1.27 would approximately be. Doesn't have to be perfect, just approximate. And it says find the area to the left of that. So we want to find the area, which is another way of saying what's the probability of everything to the left of that. Okay? Now to do that, all we have to do is use this formula. This formula will give me the area to the left of the z-score. So what we're going to do is we're just going to click on a cell, and you are going to type in norm dot s dot dist. It's really important that you have the s in there. This is a standard normal distribution. If you don't have the s in there, it's not going to give you a normal distribution. It's going to give you something different. It has to be norm.s.dist. Then you open the parentheses, and it tells you, literally tells you right there what to put. First they want the z-score, so 1.27, comma, and then true means it's cumulative, so we want true. Or you can put 0. 0 stands for true as well. Then you're just going to hit enter. That tells me that the area under the standard normal curve to the left of z equals 1.27 is 0.897958. Now, we're doing this on Hawks. They're more than likely going to say round to the 4 decimals. So I'm going to go ahead and do that so I remember. And I'm just going to move it to 4 decimals, so approximately 0.8980. Now, here's the next piece of information that is really helpful for these problems. You need to use some common sense to make sure that your question seems legitimate, okay? We know that the mean is 0, right? And the mean is exactly in the middle, okay? So what is the area of anything to the left of the mean? 0.5, right? 0.5. So we know that my answer, the area under this, should be bigger than half, okay? So if you're getting something back that's like 0.3219, you definitely did something wrong, because you know you have more than half of your figure shaded, okay? So just keep that in mind. Let's go to number 2. Find the area under the standard normal curve to the right of z equals negative 1.54. So I'm going to draw myself a curve again. And again, it's not going to be perfect. I'm terrible at drawing the curves, but I get the point. Okay? Then the mean of 0 goes in the middle. The mean goes in the middle. Now the z-score that I'm working with here is negative 1.54. So is that going to be to the right or to the left? To the left. Negative 1.54 is going to be about here. But here's where things are different. It says find the area under the standard normal curve to the right of negative 1.54. So they want the area over here. Well, the problem is my formula gives me the area to the left, right? So if I were to type in norm.s.dist of negative 1.54, it would give me this area over here, and that's definitely not what I want. So how am I going to get the area to the right of it? Why? Perfect. Reminder, the area under the entire curve is always equal to 1. So to solve this one, we know that if I type in norm.s.dist, it's going to give me this yellow portion here. So what we want to do is we want to type equals 1 minus norm.s.dist of negative 1.54, comma true. And by doing 1 minus, that's saying we're taking the whole area underneath this curve and subtracting that area to the left, and that's going to leave us with the area to the right. Does that make sense? And you should get 0.9382. 9382. So again, that's why I sketch the pictures, because it helps me remember. Can I just put in the formula? Do I need to do 1 minus the formula? That's why those pictures are so important. Let's go to number 3. Find the area under the standard normal curve between z equals negative 1.06 and z equals 1.89. So draw yourself a curve. Put 0 in the middle. And we want a z-score of negative 1.06 and positive 1.89. And I want the area between those two. I want the area between those two. How do you think we're going to do this? Find the norm disk for 1.89. That's going to give me this yellow highlighted area. So then you're saying find the norm.dist of negative 1.06, and that gives you this area, and then do what with them? Subtract them. So you're going to want to take the norm.s.dist of the bigger one and subtract the norm.s.dist of the smaller one. So let's figure out how to do that. So you can do it in 2 different ways. You can type it all in at one time. That's okay. Just make sure to close your parentheses. Or you can do each one in different cells and then subtract them after you're done. I'm going to do them at the same time. So I'm going to say norm.s.dist of the bigger one, 1.89, comma true. Close that parenthesis. And then we're going to say minus norm.s.dist of the smaller one, negative 1.06, comma true. And when you hit enter and round it to 4 decimals, you should get 0.8260. Now again, you could also do them separately. You could say norm.s.dist of 1.89 and norm.s.dist of negative 1.06. And then you could say equals this guy minus this guy, and you should get the same thing. Are you guys okay with that? Awesome. Number 4 says find the area under the standard normal curve that is to the left of z equals negative 1.24 and to the right of z equals 1.78. So I'm going to sketch this here. I don't want that. So I have my curve. 0's in the middle. And I want to the left of negative 1.24. And then I want to the right of 1.78. Do you think we're going to be able to do this all in one cell? No, we're probably going to have to do 2 on this one because it's split. Let's start with the easy one. What's the easy one, the negative or the positive? Negative. Why is this a negative? Yeah, because it goes to the left. How would I find this shaded area right here? What would I put in? norm.s.dist of negative 1.24. And then how would I find this guy to the right? 1 minus norm.s.dist. So I'm going to have to do two different formulas here. So I'm going to come over here, and if you want to organize them, you can. That's what I'm going to do. So I'm going to do the left of negative 1.24, and that's going to equal norm.s.dist of negative 1.24, comma true. And then to find the area to the right of 1.78, what did I type in again? 1 minus norm.s.dist of 1.78, comma true. Now what do I do to get the total answer, the final answer? You add them together. So my total here is going to be the sum of this one and this one. Or if you just want to put equals this plus this, that's also okay. And to 4 decimal places, we should get 0.1450. Here's what you should not do. You should not come here and goes equals 0.1075 plus 0.0375. Why should I not do that? You're rounding too soon. Don't round until the very end, because sometimes it gets you the right answer, sometimes it doesn't. Don't do that. Show me your thumb. Good, good. All right. Now we're going to go the opposite way. Now what's going to happen is they're giving me the area under a curve, and I need to find the corresponding z-score. Okay, I need to find the corresponding z-score. So find the value of z such that the area to the left is 0.9147. So here's what they're telling me. They're telling me I have a curve. So boom, curve. The mean is 0. And the area to the left is 0.9147. Is that more than half or less than half? That's more than half. So I know whatever my z-score is, it's going to be positive, because the area to the left is like 91% of it. So I know it's going to be somewhere over here. And I'm going to shade this in. And then I'm just going to do this, 0.9147. So again, I know that the area should, or the z-score should be positive. Now to do this, it's literally like the inverse of the normal standard distribution. It's saying, you know, when you have the z-score, you can find the probability or the area. This is the inverse of that. Now you have the area, you need to find the z-score. So to do that, it's norm.s.inb. So again, inverse. And then when you go of, all you have to type in now is the probability. You don't have to type in true or false. It's just the probability. So 0.9147. And again, this is a z-score, so they're going to want probably 2 decimals. So they're saying the z-score of 1.37 would have an area to the left of 90 or 0.9147. Okay, let's go to number 6. Find the value of your z-score such that the area to the right is 0.7967. So I'm going to sketch my graph here. And now we're saying the area to the right. Is the area to the right more than half or less than half? More than half. So if the area to my right here is more than half, I know that I'm going to cover all of this plus some. It's going to keep going, right? So, sorry, wasn't a great job. So I know that it's going to go past half here, which means my z-score, is that going to be positive or negative? It's going to be negative. So this is 0.7967. Now, how do you think I'm going to do this? We can't do 1 minus. And this is so weird because when you're finding the norm inverse, you're finding the z-score. We can't just take 1 minus that z-score because it's not going to give us the right value. But we can use 1 minus beforehand. Here's what I mean by that. We know that this area is 0.7967. So what does that mean this area is going to be? 1 minus that. So 1 minus 0.7967. 1 minus 0.7967, which is going to be 0.2033. And again, if you're like, I can't do that without a calculator, cool, no problem. You can just go 1 minus 0.7967. Okay? Then, now that you have the area to the left, you can do norm.s.inverse. But you need to do it of that 0.2033 because it only finds it to the left. Now that's saying my z-score is negative 0.83. Does that look right? Does that sound right? Yeah, what if it gave you back a value of 1.2? You probably did something wrong. Okay? All right. Let's go to number 7. Find the value of z such that the area between 0 and z is 0.3665. So I'm going to sketch my graph here, sketch my distribution, area of 0. Find the value of z such that the area between 0 and z is 0.3665. So I'm going to have some z-score here, and the area between it is going to be 0.3665. Okay? Now this one's a little trickier, okay? Because again, we have to find the probability or the area to the left to be able to use norm.s.inverse. What is the area to the left of 0? 0.5, right? Because isn't 0 right in the half? And then what is the area of this little section right here? 0.3665. So what I'm going to do is I'm going to do norm.s.inverse of, and I'm going to say 0.5 plus 0.3665. And like, look, I just typed it right in there. I didn't have to do it in another cell. I literally just typed it right in there. And you should get about 1.11. Thank you. Are we okay with that? Yes. Because 0 is right in the middle. 0 is right in the middle. So it splits it right in half. Now I want you to look at what else I have up there. Sometimes people get confused because it says the value of z such that the area between 0 and z is 0.3665. Well, if I have my curve, that means here's 0 and here's this. I could have 0.3665 right there. Or what if this was it? Like, could I have that section with an area of 0.3665? Yeah, you definitely could. They didn't necessarily say that the z-score was positive. So if this was the guy you were finding right here, what you would need to do is know that from here to here is 0.5, and from here to here is 0.3665. So I did the norm.s.inverse of 0.5 minus 0.3665. But if you'll notice, it gave you the exact same z-score, just negative. Okay? So you can do either one. You can do either one. I always do the positive unless they specify otherwise, because to me that's easier. It should not. Should not. Yes. It doesn't include it. I'm saying that from all the way, since like the area under this whole thing is 1, 0 is right in the middle of it, so from the very left to 0 is 0.5. So I added on this one because I said my z-score is going to be positive. So from here to here is 0.5, and then I'm adding this little section to it. But look over here, Lainey. Look over here. Here I said, what if it's on the left? And so I said, from here to here is 0.5, but I want to figure out what this z-score is, so I need to know the area from here to here. You're lying, but that's okay. Okay, number 8, last one. Find the value of z such that 0.6826 of the area lies between negative z and positive z. This one's crazy. So I'm going to sketch my distribution. I'm going to put in 0, okay? I do not know what the z value is, but I know that I'm dealing with the exact same number, positive and negative. So I know that it's going to be here, this is going to be negative z, and here this is going to be positive z, okay? And they're saying the area between them is 0.6826. What do we think? Now remember, if I do norm.s.inverse, it's going to give me the z-score of anything to the left. So if I type in norm.s.inverse of 0.6826, it's going to find that like here's about 0.6826 and give me everything to the left of it. That's not what I want, okay? Instead, we need to figure out how to get the between. Why? Okay, you're on the right track. You're on the right track. What about this area right here? Could I figure out what that is right there? How? 1 minus 0.6826. Okay, so if I type that in, where's my mouse? Equals 1 minus 0.6826. That's going to give me 0.3174. Why do I have to divide it by 2? Good, because that is both of those blue areas, okay? And so I want to divide that by 2 because it's going to be symmetrical. So that means that here is 0.1587 and here is 0.1587. Now what? So I could do norm.s.inverse of what? 0.1587. And we want 2 decimal places. What does that mean? Like, what's my answer? 1? Like, the question was, what are the 2 values of z? I have 2. So what's this value of z going to be? Negative 1. What's this value of z going to be? Positive 1. So the area between negative 1 and positive 1 is 0.6826.